The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I'll respond as soon as I can. All right, so I had a couple of requests, and this is from section 8.3, number 5. So this takes us back a couple of days. Can you see the WebAssign screen on the left side? Somebody let me know just for sure. Anybody? No one? No
Yes,
one?
I can see it.
Thank you. Thank you. Because
Yeah.
sometimes I push the wrong button, as I've often said. Okay, so refer to the graph to find each value. So basically what we're doing here is completing ordered pairs. This first one, part A, it says find f of 2. So the input is 2. We want the output of this function, which is labeled f. So on the graph of f, we want to find the point that has an x value of 2. This point right here has an x coordinate of 2, and the corresponding y coordinate is 4. Therefore, f of 2 equals 4. Any questions on that? All right. Part B says find f of 0. So again, we go to the graph. We want to know the y value when the x value is 0. Well, the x value is 0 right here. So is the y value. This graph goes through the origin. So those two problems were given x, find y. Now we're told that f of x equals 4. Well, that's another name for saying y equals 4. What value of find the value of x for which y or f of x is 4? Well, f of x or y equals 4 is right there. What's the corresponding x value? 2. So for f of x equals 4, we'll say that x equals 2. Okay. Part D, for f of x equals -2. So now y is -2 right there when x is -1. Any questions on this problem? All right, we've got one more. We're going to take a look at problem number 6, again from section 8.3. And part A says find g of -1. Part B says find g of 0. Part C, find the value of x for which g of x equals 3. And then part D, g of x equals -1 when x is what? Okay, so same idea as before. G of -1, they want to find the corresponding y value when the x value is -1. Well, x equals -1 is right there. The corresponding y value is 3. G of 0. The x value equals 0 right there. The corresponding y value is 2. What's the value of x when g of x is 3? So what's x when y is 3? Y equals 3 right there when x is -1. And part D, the value of x when g of x or y equals -1 would be +1. Oh, the values of x. There's 2 of them, aren't there? There's x is -3 and x is 1. So x is -3 and x is 1. So there are 2 input values, -3 and 1, that both give the y value or the g of x value of -1. Any questions about that? All righty. Do any of you have any questions from WebAssign before we go on? Okay. Give me just a minute here to switch the screens around. Hang on. Okay. So once more. Okay, we should be back in business here. Today, we're going to look at section 8.9. And tonight's assignment will be section 8.9 in the chapter review. Tomorrow, we will review the chapter 8 test in class. And then Monday is when you will take your test by, no later than Monday at 11:59 p.m. As before, you can take your test early anytime, but once you open it up, the time starts, okay? But the test is scheduled for Monday. So Monday, there won't be any regular class meeting, but I will be there at 1:15 for an office hour. Tuesday is advising day. So after tomorrow, I may not see you again until Wednesday, okay? So again, tomorrow we're going to review. The test is Monday. Tuesday is advising day. Wednesday we'll hold regular class again. And I'll repeat all of this again tomorrow for those of you that show up for the review. Anyway, okay. Section 8.9 has to do with something called variation. There are three types of variation that we're going to look at. The first type is called direct variation. In general, it is of the form y equals k times x, where x and y are the variables, and k is called, so k is called the variation constant. Helps if I can spell. Constant. It's also referred to as the constant of variation, and sometimes even the can't even talk, the constant of proportionality. I choose variation constant because it's the shortest. But so it is not a variable, but we have to determine what it is. So the way this works is we'll have an example, which I'm going to do. We'll plug in some numbers that will allow us to determine what k is equal to in a given scenario. And then there'll be a follow-up question using the k value that we find. All right. So here's the first example. It says free fall. An object in free fall, so something that's falling freely, travels a distance s that varies directly to the square of time t. So s varies directly to the square of time t. Now, k, or the variation constant, is rarely mentioned. Sometimes it's mentioned, sometimes it's given, but most of the time you just have to know that you need to include it and find it, okay? So it says direct variation, so I'm using the model y equals kx, but my variables are s and t. And again, it says an object in free fall travels a distance s that varies directly to the square of time. So t is time, that's why I've got t squared. Any questions about where I came up with this formula? Okay. So now we're going to use that in a follow-up. If an object falls 1,024 feet, so that's s, in 8 seconds, now don't forget that time is squared, how far will it fall in 10 seconds? So again, a common mistake is that students going from here to here will drop that exponent of a 2 and then their answer is incorrect and they can't figure out why. So what have I got now? I've got 1,024 equals 8 squared is 64 times k. I can now come back and divide both sides by 64. So on the calculator, let's see, 1024 divided by 64, and I get K equals 16. I then take that value and plug it in there. So now my formula is S equals 16t squared. I'm going to use that for the follow-up question. How far will it fall? So that's S in 10 seconds. So S equals 16 times 10 squared is 100. So 1,600 feet. And there's the final answer. So what are the steps? We need to read the problem through to determine what kind of variation it is. Now, we've only talked about direct variation so far, but we're going to be looking at several different kinds, 3 different kinds. But this one's direct variation. They give us the variables. We set up the equation. They give us some information to allow us to determine what K is. We solve for K, put that value in there, and then use the follow-up question. Any questions about this example? All right. Next kind of variation, inverse variation. Y equals K, over X. So now we have this reciprocal situation. K is still present, K is always on top, but now the variable X is down below, okay? So here's an example. It says, the frequency of vibration of air in an organ pipe, a pipe organ, you know, like in a church, anyway, varies inversely to the length of the pipe. If a pipe 2 feet long vibrates 256 times per second, how many times per second will a 6-foot pipe vibrate? Okay, let me look at this again. It says the frequency of vibration of air in an organ pipe varies inversely. So we've got the frequency of vibrating air. How about if we let F equal frequency of vibrating air, okay? Varies inversely to the length of the pipe. Let's call L the length of pipe, okay? So the frequency of vibration of air in an organ pipe varies inversely, so F varies inversely as the length of the pipe. Again, notice K wasn't mentioned, but I know where F and L go because it's inverse variation. Any questions about that? All right, now, if a pipe 2 feet long vibrates 256 times per second, so 256 is the frequency of vibration, L is the length, which is 2 feet. This allows us to solve for K. We'll multiply both sides by 2. K equals what? 512. 2 times 256. So then that goes in the place of K, and our equation becomes F equals 512 over L. So it was inverse variation. We used the inverse variation model. We determined the variables, set up the formula, put in some information to solve for K, replaced K in the formula. So now we have a formula to use for the follow-up, which says how many times per second, so that would be the frequency, will a 6-foot pipe vibrate? Okay, so 6 goes in the place of L. And let's see, 512 divided by 6, I'm getting 85.3 repeating, which would be 85 1/3 times. Now, if this was a web-assigned problem, you would need to basically take 512 over 6 which would be what, 256 over 3. I think that's right. And that's the number you would put in. Again, in WebAssign, don't use mixed numbers and don't use decimals that you've rounded off. I believe there is a way to write a repeating decimal, but I don't remember how to do it. I'm not even sure if you can. But again, if this was a WebAssign problem, you would put 256 over 3 times. Any questions about that? Okay. Our third and final type of variation today is joint variation. Y equals K. And let's see, what did they use? I think they used W. Doesn't really matter. They use X and Z. Okay. So what's going on here is that we have more than one variable on the right side of the equation. Think about a joint checking account. I don't know if any of you have one. Let's say you're married, you and your spouse share an account. It's a joint checking account. Okay, more than one person can use it. This is joint variation, more than one variable on the right side of the equation. All right, here's an example. It says the number of gallons of oil that can be stored in a cylindrical tank varies jointly as the height of the tank and the square of the radius of its base. The variation constant is 23.5. Find the number of gallons that can be stored in the cylindrical tank. All right, they give us a picture of the tank. So let me attempt to draw it here. And they tell us that the height of the tank is 20 feet. And the distance across it is 15 feet. I think it's interesting. The picture looks like this, but obviously from the measurements, the picture isn't accurate, is it? It looks like it's wider than it is tall. But anyway, they give us the numbers. Okay. So the number of gallons of oil that can be stored in a cylindrical tank. So how about if we let G equal number of gallons, okay? And then let's see, the height of the tank would be 20, or H would be 20 feet, wouldn't it? And the radius, what would the radius of the tank be? Anybody? Is it 15 feet? The 15 feet, go ahead, what?
I just said, yeah.
15 feet is the diameter. What's the radius? Half of that. So let's go ahead and use a decimal, 7.5 feet. So from the picture, the height is 20 feet, the radius is 7.5 feet. G stands for the number of gallons, okay? Let's go back and I'll read the problem again. The number of gallons of oil that can be stored in a cylindrical tank varies jointly. So G varies jointly as the height of the tank, which is H, and the square of the radius. All right, so there's our joint variation formula. It goes on to say the variation constant, in fact, in this problem, they call it the constant of proportionality, same thing, is 23.5. So we know that K is 23.5. In the first two examples, we had to determine it. In this example, they're giving it to us. So we've got G equals 23.5 times H, which is 20, times R, which is 7.5 squared. It says find the number of gallons that can be stored in the cylindrical tank. So we just need to do the calculations. So G is 23.5 times 20 times 7.5 squared. We get 26437.5, and that would be gallons. Any questions about that?
Where did you get that number from?
Which
Did
one?
you just, the 26,437? Did you just times all that?
Yeah, I just
together?
calculated that all out on a calculator.
Oh, okay.
23.5 times 20 times 7.5 squared, yada, yada, yada. Yeah,
Mhm.
okay.
Oh,
Any other questions on this example? So we've got direct variation, inverse variation, and joint variation. All right. So you want to familiarize yourself with those three forms. Now I want to do some translating where I'm going to read a statement. Maybe I'll just write it out and then we'll write it in variables or in letters. So this first one says A varies directly as the square of P. So A equals K P squared. Any questions on that translation? All right. T varies directly as S. So T equals KS. Questions? Okay. Z varies inversely as the cube of T. So Z equals K over T cubed. V varies inversely as the square of R. So V equals K over R squared. Again, any question on those? All right. C varies jointly as X, Y, and Z. So C equals K, X, Y, Z. So joint variation can have more than two. In this case, it has what, 3 variables on the right. It just means there's more than one variable over there. 2, 3, 4, etc. Okay. Now, how about this one? It says P varies directly as the square of A and inversely as the cube of J. So we've got two kinds of variation going on in the same formula. P equals K A squared over J cubed. Okay with that? So we've got the direct variation and the inverse variation together in the formula. All right, now we're going to go the other way. I'll write the formula, then we'll put it in words. R equals KT. So R varies directly as T. B equals K over H. Excuse me. B varies inversely as H. Let's see here. U equals K R S squared T. U varies jointly as R the square of S and T. And then here's the last one. P equals Km over N. P varies directly as M and inversely as, is that supposed to be an H? No, it's an N, as N. I've warned you of this before, but let me warn you again. In WebAssign, don't change the case of the variable. So if it's like a capital P and then you write a lowercase p, it's going to mark it wrong and you'll be going, what's wrong with this? You know, so make sure you use the same case for the variables. All right. Any questions about that? So direct variation, inverse variation, joint variation. All righty, well, that's all I've got for you. So tonight, you've got section 8.9 and the chapter review. Tomorrow during class, we'll review. Again, your test will be Monday, and then Tuesday is advising day, and Wednesday we'll meet again. But I will be back this afternoon at 1:15, and I'll be back tomorrow with a review session for anyone who cares to show up. I will now stop the recording.